Hello, morning class. So today we're going to discuss the paper 1 MRSM 2019. Okay, based on the message from the group, you all require me to answer questions 3, 5, 11, 14, 16, and so on. Okay, so questions 3. Diagram 1 show the vernier caliper. What is the reading of the vernier caliper? Okay, actually there's no correct answer for these questions. Okay, because how to read this vernier caliper? Okay, the way to read is you have to read the first line here, which is 0. Where is it 0? So on the mean scale here, you got 1.1. Okay, this 1.1 is centimeter. And then for the vernier scale here, actually the best is a line. The best one I think is, I think we agree with 4, right? So for these questions, the answer will be 1.1 plus 0.4, so it's 1.14 centimeter. So there is no correct answer for these questions. Okay, so the correct answer is 1.14. Okay, next questions will be questions 5. Okay, for questions 5, diagram 3 show a motorcycle going up a hill. The motorcycle decelerate as it moves up the hill and accelerate as it moves down the hill. So in very common, it's very difficult for us to move up the hill. Okay, if you're moving up, the velocity going to reduce. Okay, usually it will be like that, right? So when you're moving down, the velocity going to increase. So based on this, based on the upper phenomena, so which graph represent the best? So at the first part here, the velocity going down, and the second part after the hill, so the velocity move up. So the best answer is will be answer B, because the velocity at the first part it drop and then increase again. Okay, so the best answer is B. Okay, so that's it for questions B and questions 5. Next, questions 11. Questions 11. Okay, in diagram 8 shows a student pulling his friends having 40 kilograms on a trolley at constant velocity. So these are the keywords. It's very important keywords that you have to know. So when you say constant velocity, that means that A is 0 and there's no accelerations for this motion. So what is the frictional force acting on the trolley and his friend if the tension of the rope T is 400? So here will be 400 Newton. Okay, so first part we have to find if we resolve this force, if we resolve into x and y axis. So actually these tensions we can resolve into x and y. Okay, so actually if you draw 400 like this, you can draw a right angle triangle. So remember, for the horizontal here, you're going to use what? And you're going to use sine or cos. Okay, so I guess now, so many we try with many questions, and in MS, in math, you also learn. So this one we're going to use cos, because cos is adjacent over hypotenuse. Okay, so to find what is the fx on horizontal, we're going to use 400 Newton times cos 30. Okay, 400 Newton times cos 30. Okay, so after you calculate, you will have 346.41 for the horizontal force. So this force actually moving to the right. So for the motions to be constant velocity, and that means there is a force in opposite direction. The total force of frictions will be the same magnitude but in opposite direction. Okay, so the answer will be C. Okay, next. The next questions will be 14. Okay, next question is 14. Okay, this one is about spring. Okay, how we arrange a spring. So you can read the questions. The diagram show all the springs are identical here, but the arrangement is different. And the mass here all have the same mass. So which comparison is correct about the compressions P, Q, and R? So let's say, okay, when we put a load on the top of the string, of course, before this the spring is longer than the one now. So the extensions, let's say this one is not extension, this one is compression. The length of the spring reduced. So let's say the length of the spring reduced is x. If you put a mass here, then the compression is x. But if you arrange the spring, you got two spring. Okay, distribute the load, distribute the weight of the load M. So actually, one of it will experience half of the force of the weight on the load. So for this case, okay, the compressions will be reduced to half for this case because the weight already supported by both spring. Okay, and this arrangement we call parallel. Okay, for the third case will be, okay, you got 4 spring. Okay, let's say we had to divide by level and level. For this case here, okay, because 2 spring again is similar to this situation, we have to imagine that the upper spring is not there. Okay, for the first layer, so here actually we are going to compress by half x also because we got 2 spring arranged in parallel. Okay, and the upper parts here also will be compressed by half x. Okay, but the total, when you sum up the total up, the compression for both for all the spring here, for both upper and lower parts will be x. Okay, so in this case, P and R have the compression of x. That means P and R are the same. P and R are the same. Okay, so find the answer from here. So the best one is P and R are the same. Okay, so the best one is this one. Q is less than P equals to R. That means P is equal to R, and then the extension is the compression is higher than the Q. So the best answer is A. Okay. So we continue in the next video for the next questions because I can't make the video too long, very hard to upload. So thank you.